So we all have this page of notes. Let's start by doing just a quick review on graphing. Go ahead and plot, or not plot, but state the coordinates of those points. I want to hit pause. 3, 4. Why 3, 4? Because you go 3 on the x, 4 on the y. That's how to get to location A. How about B? Negative 1, 3. Negative 1 on the x, 3 on the y. How about point C? How do I get there from the origin? 0, you don't go anywhere, negative 2. 0, negative 2. And point D, the last one, from the origin. 4 on the x, 0 on the y. Perfect. 4, 0 is the coordinate. Now, we need to be able to graph coordinates in order to graph lines. Okay, so let's move on to today's notes. Now, we're going to be talking about functions and relations. So, in this section, we need to define and understand what a function is and compare it to a relation. So, I know we might not have the same artistic abilities as me, but go ahead and draw something that's kind of like that. As you draw this, the important part is that you have an opening so you could plug in values, and then a window so we could actually see inside and see what's happening, and then the output comes out here. So an opening to go in, a window to see what's happening, and an opening so that your new values come out. And this is what a function is like. Whenever I hear the word function, I think function machine. So go ahead and draw it. Okay, guys, so obviously it doesn't have to be perfect. Any type of machine will work. Now, this is what we want to do. I want to write a number. Give me any number you want. 3. So I want to take the number 3, and I'm going to plug it in. And when I plug in the number 3, it comes out as a 5. Okay? Now, give me another number. 6. I want to take the 6, and I want to plug it in, and inside the machine, something happens to that 6, and it comes out as the number 11. Give me another number. 2. I plug in the number 2, and inside something happens, and when it comes out, I get the number. Does anybody know? 3. 3 is correct. 3 is correct. If you haven't figured it out yet, let's try another number. How about the number 10? If I plug in the number 10, I get out the number what? 19. Somebody has it. Okay.
Oh, you add.
So what? So you should be asking yourself, what do I do to this 10 to make it become 19?
Add 9. I know.
Or
add 3 and 6.
Add 9 or like multiply
Maybe.
it by 2
and then subtract.
multiply by 2.
Okay, you subtract it and then you multiply it by itself. Or like
Subtract it and then multiply.
you subtract 1 and then you multiply it. Or you.
Okay, wait, guys.
No. You. Okay.
Enrique, say what you said louder.
Multiply by 2.
Multiply by 2 and subtract 1. Multiply it by 2 and subtract 1. So if I take the 3 and multiply it by 2 and subtract 1, 3 times 2 is 6. 6 take away 1 is 5. 6 times 2 is 12. Take away 1 is 11. 2 times 2 is 4. Take away 1 is 3. 10 times 2 is 20. 20 take away 1 is 19. So when we take a look at the inside of this machine, what's really happening in there is y equals 2 times your x value minus 1. Guys, I'm hearing a lot of talk. I hope it's about this math. Okay? But this is what's happening, guys. You take the 3 and where do you put it in? You put it into the x or the y? The x. So when you say 2 times 3, that's 6. 6 take away 1, that's 5. And now it really says y equals 5 when you plug in the 3. So that's why 5 is the output. Okay? Plug in 6. 6 gets plugged in right into the x. 2 times 6 is 12. 12 take away 1 is 11. So for my input 6, I get the output 11. And when I say output is 11, that really means 2 times 6 is 12, take away 1, y equals 11. So it's really important that we understand this diagram And not only that, that we understand the words that we're using here. We need to have all of these words in our heads. Input is the same thing as X values. And that makes total sense. So what do I do with the 3? I put it in. It's an input. Where do I put it in? Into the X. So when I get out an answer, my output is really the Y value. So inputs are X values. Outputs are Y values. Does that make sense?
Yes.
Okay. Now, the only one that's kind of tricky is domain and range. Okay. Domain is also the same thing as X values. It's also the same thing as inputs. Okay. So all of these numbers that we're putting in are domain values. All of these numbers that we're putting in, they're also X values. The ones that come out, those are called outputs. The ones that come out, those are called range values. The ones that come out, those are called Y values. So we need to know this. We need to know inputs are the same thing as domain values, same thing as X values. Outputs, same thing as range values, same thing as Y values. Now, what form is this equation in?
Y equals mx plus b.
Function form. Right? We already did function form before. Function form is simply getting y by itself. And why do we call it function form? Because when it's set up like this, y equals, it's really easy to plug in numbers and pull out answers. To plug in your X values and get out your Y values. Now, the most important fact of the day is with regards to functions. For each input, there's exactly one output. In other words, if you plug in a number and you get out an answer, then you plug in that same number again and get out a different answer, then it's no longer a function machine. The machine's messed up. If you put in one thing, you have to get out only one thing. If you ever end up with 2 outputs for your one single input, then you cannot consider it a function. It's just a relation. Now that could be confusing. That paragraph could be confusing. But let's go back to this machine here, and let's think of this as a donut machine. Okay? If I plug it, forget about numbers. If I plug in some dough and I get out a donut, and I plug in some more dough, what am I supposed to get out? A donut, right? Plug in some dough, get out a donut. Plug in some dough, get out a donut. What if I plug in some dough and get out a tortilla? Then the machine's broken. The machine's broken. So the idea is this, guys. For each input, there has to be exactly one output. So if I ever plug, like right here, I plugged in a 3. What did I get out? A 5. If I plug in a 3 again, what am I supposed to get out again? A 5. But if I plug in a 3 and I get out a 5 and I plug in a 3 again and I get out a 7, then I know my machine is messed up. So for each input, there's exactly one output. Okay? If you ever plug in the same input twice and get out different outputs, then you know your machine's messed up. Okay? So let's go down here and let's analyze whether these groups of numbers represent a function, which is like a machine, or just a relation, right? So if we look at this first input-output chart, our input 1 gave us the output 3. Our input 2 gave us the output 4. Is this a function? Is this a machine, or is it a broken machine?
It's a broken machine.
It's a machine that works.
Dang it.
Now, why is that? We never plugged in the same number twice and got out different answers. So if I would have another number 2 right here that gave me a 5, then that would be a broken machine, right? Look, we plugged in a 2, we got out a 4. If you plug in a 2 again, you're supposed to get out a 4 again, right? But right here, I plugged in a 2, got out a 4, plugged in a 2 again, got out a 5. Then the machine would be broken. But that's not the case on this example. We didn't have this. So they want us to label this as a function or just a relation. And this is definitely a function. So everybody write down function right here. Now, why is this a function? Because we never plugged in the same number twice and got out different answers. Now, I mean, I don't even want to know what the function is. So once again, guys, all I'm asking for, is it a function or just a relation? If the machine's working, you say it's a function machine. If it's not working, you say it's just a relation. So, like, I could even take it a step further and say, what is the actual function form equation that produces these outputs for these given inputs? Then you would say y equals Well, what happens to the 1 to get to a 3?
You have to multiply it by 2
And then subtract 1? Okay, if I multiply 2 by 2 and subtract 1, will I get 4? No. So how do I get from 1 to 3?
Oh, you just add 2 on all of that.
Yeah, you just add 2. So right here, it would say y equals, take the x value, your input, and just add 2 to it. That would be the actual function that represents this input-output table. Now, you don't need, okay, this is just a bonus. Yeah, we saw it, that's great, but we don't need to do this. We don't need to write down the function form equation. All you have to do is give me a f or an r, and that's an f. It's a function. Why is it a function? Because you never plug in the same number twice and get out different answers. Let's look at this one over here, domain and range.
That's wrong. That's an R.
Now, domain and range is the same thing as x, y, or input, output. So this is broken, right? Why is it broken?
Because there's
2 negative 3s and they're both something different.
Yep, the negative 3 gave me a 15. So if I plug in the negative 3 again, it's supposed to give me a 15 again, but it gives me something totally different. That's like saying I plug in some dough, get out a donut, plug in some dough, get out a tortilla. The machine's messed up. So right here, we don't say F. What do we say? R, as in relation. Now, what does that mean? The machine's broken, but we still know that there's some type of relationship going between these and these, right? But we just can't narrow it down to like a y equals 2x minus 1, okay? So how about this guy over here? X's and Y's, coordinates. So is this a function? Is it a machine or is it a broken machine? It is a function. Some of us are thinking, wait a minute, what about all these 3s? So what? As long as you don't plug in the same number twice that gives you different answers, then it is a function. Okay? So I could even be real specific. The function form equation that would actually give us these inputs and outputs, it would be y equals 0x plus 3. Now, you don't need to know this. Is just a bonus right here, knowing the actual function. But think about it. Plug in 4 right there. 4 times 0, 0 plus 3 will give you the output 3. Plug in 2. 2 times 0, 0 plus 3 will give you the output 3. So this is definitely a function, not a relation. Function, not a relation. Let's go up here. We also need to determine just by looking at a graph whether it's a function or a relation. So if we look at this line right here, is that a function or is it a relation?
It's a function.
Now, you don't know yet, but any graph is just an infinite amount of coordinates. Look, all of those coordinates are actually x and y values. I've listed the x and y values right there for each of those points. Coordinates. So you never plug in the same input more than once, right? They're all different inputs, so that right there we know is a function, so everybody put an F right there. But there is a shortcut. Instead of looking at the x and y values, instead of thinking of inputs and outputs, there's a shortcut called the vertical line test. Okay? So what is a vertical line test? You get a vertical line like that, and you just run it left to right. So this graph that we have will never touch this blue vertical line at more than one point. So that's what we call passing the vertical line test. And that means that it is a function. Let's go to this next one over here. Does this pass the vertical line test?
Yes.
So if I stop my blue line right there, how many places does it cross the blue line? One.
Once.
Does it ever stop? Does it ever cross at more than once? No. Like right here, it crosses right there. When I move it over here, it crosses right there, only at one spot. So this does pass the vertical line test. So this is a function. Everybody should put an F right there for function. How about this guy down here? Does it pass the vertical line test?
No.
It does not. As you can see right there, the blue line touches the graph at more than one point. So this right here is a relation, not a function. It's a broken machine. I mean, I could be very specific and say it's broken because for the input 4, I get two different outputs. What are they?
-2 and 2.
Yep. You get the -2 and 2. for the two different outputs. So we know that machine's broken. Okay? Makes total sense. How about this guy? Is that a function or a relation?
It's a function.
It is a function. If you do a vertical line, it'll only touch it at one point, never at 2 points. So that does pass a vertical line test. That is a function. Everybody label it function. You are going to have to do this on Friday's quiz. Right here, if I take this vertical line, so that blue line, when it touches the actual graph, does it have any points in common?
Yeah.
All of them, right? So that right there fails the vertical line test, so that's just a relation. That's a relation. Put an R. You could even think of this in terms of coordinates. What is that coordinate? That's a coordinate 2, 3. What's this coordinate? That's a coordinate 2, 0. So as you can see, the input 2 is giving you different outputs. That machine's broken. How about this one? Does this pass a vertical line test? No way. Right here, at that input of 0, how many outputs do I get? I get 3 different outputs, right? Like maybe right here, the input 0 gave me the output 0. Right here, probably positive 4. Right here, negative 4. I don't know exactly, but I do know that it fails the vertical line test because for my input of 0, I get these 3 different outputs. So the vertical line test is the quickest way to determine if you have a function or just a relation when it comes to graphs. Jumping down to the bottom of the page, it says determine if the graphed coordinates on the class opener represent a function or a relation. So if we go up here to the class opener, does it pass the vertical line test? If I run my vertical line, is there more than one dot on my vertical line?
No.
So does it pass the vertical line test? Yes. So is it a function? Yes, it's a function. So number 1, it is a function, not a relation. Number 2, it says, please state the range of the class opener. What does that mean, state the range of the class opener?
How long it was, right?
If you look back at your diagram, the range is just a different word for y values. So when I ask you to state the range of the class opener, what are you going to write? 4, 3, negative 2, 0. Believe it or not, there's questions like this on the final. Super easy. All you got to understand is what range actually means. It means y values. So 4, 3, negative 2, 0. So the range is 4, 3, negative 2, 0. Those are the range values of the coordinates that we have on the class opener. Let's go and state the domain of the class opener. So the domain values must be what? The x values, 3, negative 1, 0, 4. 3, negative 1, 0, 4. Those are the domain values, the x values, these guys right here. So the domain are 3, negative 1, 0, and 4. Number 4, if you have 2 different domain values producing the same range value, then it cannot be a function, true or false. Now you might want to think, instead of domain, you might want to think something that helps you a little more like input. So if you have 2 different inputs giving you the same output, then it cannot be a function. What do you guys say, true or false? That is false. Okay? As you could see on this example, we had different domain values giving us the same range value. So it could be a function. Number 5, if you plug in a 3 and you get out a 4, then you plug in a 3 again, but you get out a 2, then it's not a function, it's only a relation. True or false?
True.
True. Good. So we are going to have a homework assignment based on this stuff. Here it is. But we're not going to do this on this video. It's already way too long. Guys, I do apologize. The instructions aren't that clear right here. For numbers 3 through 8, instead of yes and no and why, let's write down function or relation and why. Okay? So you want to look at right here, you're looking at x and y values. You're looking at input-output values and determine, is it a function or is it just a relation? And also give a reason. Okay? We'll go over this over the next video.